What's good, Year 11 VCAL Numeracy class? Mr. Herman here. In this lesson, we'll be looking at log 4, 36.4 graphical presentation. There's only one question for this, but there is a bit of explanation that goes along with this, because the examples on the textbook don't go through different types of categories of data. So this is what this video is going to be dedicated to. So log 4, and this is going to be graphical presentation. And before we get to graphical presentation, or before we look into ways that we can represent data through graphs, there's something that we need to look into, and that's different types of data. What do I mean by different types of data? So we know data is specifically collected information that we obtain through either surveys, questionnaires, observations, experiments, tallies, popularity polls. There are different ways that we can obtain information, which we consider data. Now, the different types of data or information that we obtain can be split into 2 different categories and then 4 subcategories from there. So say, for instance, we get data, okay? We obtain data through one of those many ways that I was explaining before from my list. This then gets split up into 2 main categories. So the first one is considered as categorical data. Categorical data. And the second type of data is considered numerical data. So 2 main ways, categorical data and numerical data. Categorical data can be tongue twister sometimes. All categorical data means is, say for instance, we did a survey and I was to go around and ask a question, hey, what is your favorite color? What is your favorite AFL team? What is your favorite this, that? What type of favorite music do you listen to? It generally has a favorite or a preference of some sort, but the results that are provided to me can only be some form of a category. It can't be a number. It's only some form of a category. So I like to think of categorical data as not numbers. Okay. And numerical, as you can obviously tell, is the opposite categorical. It's numbered answers. So if I were to do a survey and I ask, how many siblings do you have in your household? Or what is the number of your street address? What is your arm span or your height in centimeters? How much do you weigh? What is your hair length? Any type of solution that is given as a number, this is considered as numerical. Now, it's really simple between categorical and numerical. I provide a solution or an answer of some sort, and you can either have it as a category or a number. But then where it gets a little bit tricky is that there are actually 2 more subcategories that branch off from both of these. So the first one, for categorical, the 2 subcategories we can have is either, for categorical, is nominal or ordinal. Okay. So we have categorical data, okay? We have some type of data that's provided from survey. What is your favorite this or that? Nominal just means random categories. And this isn't going to make sense until we understand what ordinal means, but nominal just kind of means random. So I could talk about, what is your favorite AFL team, as I said before in the previous example. What is your favorite color? Essentially, there's no ranking with it. You can't rank your favorite color or AFL team in any way. Yes, you can rank AFL teams based on a ladder of some sort, but that is nothing to do with an actual survey itself. Where ordinal, if you have ordinal type of information, this can be ordered or ranked in some form of measured way. So for instance, I can ask the survey question, what is your favorite size cup of coffee? And I asked this question to people who were at Starbucks sometime. And they can answer either small, medium, or large. Now, it is categories, that's correct. You can either have small, medium, or large. But there's no randomness to it. This actually can be categorized in a specific order from smallest to largest. Same thing with what is your favorite meal size when you go to KFC? Small, medium, or large. Here we got Imogen Kane. Awesome, thank you. She asked a question in regards to one of the log 5, I think. So, Imogen, if you're watching this, you made the edit. So generally, ordinal, you can only rank it through a measurement of some size of some sort, where nominal is random. Okay. Now, straying away from categorical, we'll get into numerical. So an answer that's given as a number. Again, there are two specific ways that you can get nominal. Nominal. I got numerical and ordinal mixed up. Numerical. There's either discrete, or there is either continuous. I'm going to move myself to the side here. Okay, so discrete and continuous. In other words, discrete is whole or countable numbers. Countable. Where continuous numbers. Oops. There we go. Numbers given as either a decimal or as a fraction. Okay. And generally this is provided as some form of a measurement. So we can talk about weight, height, length, centimeters, kilometers, time frames, you name it. If it can be given in some form of a decimal or fraction, it's considered as continuous. Now, a lot of you are thinking, can't or doesn't every single type of numerical answer, all of them can be provided as a continuous number? The answer to this is no, because I could ask a specific discrete numerical survey question that said, how many siblings do you have in your family? You can't provide me with a decimal or a fraction number. The only answer you can provide is a whole number. Now, a lot of students are thinking, what about a half brother? Yes, they're considered a half brother label-wise, because half brother just means a brother from either a different mother or a different father, but that doesn't mean in the literal sense a half brother. It's not a half person. And I know there are still people out there, smart Alex, who think, yeah, they're half brother, half the size, no, okay? You can't have that. It's a whole number that you can provide. You can either have 0, 1, 2, 3, 4, 5, etc. onwards. You cannot have a decimal or a fraction of a brother or a sister. End of discussion, end of argument. Okay, I get it every single time. Generally, this has to do with countable. That's why I wrote countable within this explanation. It's a countable. So generally, a numerical discrete question starts off with how many so and so. You can only give a discrete countable number. So another observation that you can think of is someone wanted to check how many people came into a certain shopping center during lunchtime, and they were standing there and they had a counter and they were counting people going in, you can't get half a person coming in. Okay, again, I've heard it all. What happens if a midget walks in? Trust me, I've heard it. Doesn't work. Okay, countable. Sorry to go into a little rant there. Countable is a very, very simple type of numerical data. The amount of discussions and debates that I've had with students. Anyways, continuous. Numbers given as a decimal or a fraction, and generally has to do with measurement. This is where you ask a survey question: what is your height? What is your weight? How many cups do you put into, say, flour, or how many cups of flour do you put into a cake recipe? These answers can be given as a decimal or a fraction. You can put 1.5 cups, 1.25 cups, 1.8 cups. Your measurement, you can answer 36.32. What's the degrees? 19.85. If it can be answered as a continuous or decimal fraction, this is considered as continuous. Okay, so with continuous, if you get a question and it asks you what type of data is this, is it discrete or continuous? If the solutions provided are only whole numbers, but it can be considered as, you can have answers that are considered as decimals, even though you might not see decimals in them, it is still considered as continuous. And you will see this question pop up in the example, which I'm going to show you a little bit later on. So you might have information that's considered in a discrete way. You have numbers that's given as discrete, but if they can also be considered as continuous, or in other words, they can be written as a decimal or a fraction, it's considered as continuous. Okay. When we think of discrete, we always think of the word countable. Okay. So now we're going to have a look at the different examples from the textbook, and you're going to answer question 1. Just bear with me, guys. So we are now looking at how to graph the different types of data that have been provided to us. Now, you can either graph them in bar charts or pie graphs, histograms, stem and leaf. There's different ways that you have heard throughout secondary school and even primary school of how to graph these. We're going to be looking at column graphs, also known as bar graphs or bar charts, because they are known for having their different types of bars within a graph. But specifically, when we look at categorical data, so data that can be put into categories, we put these within what's called a column graph. And a column graph, when we have categories of some sort, so I'm just scratching my back, when we have categories of some sort, say for instance we do a tally and we ask who is your favorite solo artist singer currently, all the different categories would be put here, and you'll have a title underneath with all the different solo singers. Yeah, okay. On the side, you will have the amount that has been given in regards to popularity. So maybe 13 people answered this one, and then 17 here, and then 20, 21, 17 again, 14, and 6. Okay, maybe that's just popular. That's just a rough example. Okay. One really important key feature is that for categorical data, there are spaces in between each bar. Okay? There are spaces in between each bar. This is a very, very important feature. Heck, one of the most important features when it comes to categorical data, more importantly, column graphs for categorical data. There needs to be spaces in between. If there are no spaces in between, you are referencing a histogram, which is something a little bit different. In fact, histograms have to do with numerical data. And regardless of whether it is continuous or whether it's discrete, you will still be dealing with histograms. Histograms, you'll notice there are no spaces. In fact, these bars are so close to each other that they're touching. They are touching bars. But they are touching. We're dealing with numerical or numbered answers, and you have to, because at the bottom here, the solutions that are provided have to be given as numbers. So for instance, this histogram that's considered as continuous data, I might ask a question. Just trying to think of a question that has to do with the context between 4 to 12. Maybe you can think of a question that says, what is the measurement of your thumb in centimeters? I'll be surprised with somebody who has a 12 centimeter thumb. But in this case, or even a 4 centimeter thumb. But in this case, the information, the numbers that are provided, their solutions, is considered as numerical, so we can put this into a histogram. And if it's discrete, whether it's whole numbers, you'll notice that the difference is because whole numbers can only be given, you cannot necessarily put them or chunk them into an interval like we did here. So sometimes this might be considered solutions in between 4 and 5. In between 4 and 5. Where here, when it's discrete data, when we're dealing with whole numbers, I can only provide an answer as a whole number. So maybe, for instance, how many sporting equipment do you have in your bedroom currently as we speak? Someone could answer 4 or 5 or 6 or 10. Several people could answer 10. You can't have 4.5 sporting equipment. Doesn't make sense. But the actual bar itself lines directly in the middle of that number itself. Where if it's continuous, it's in between the interval of 4 and 5. So that means, in this case here, we might have 6 that lie within this interval. That means 6 answers were provided to me that lied in between 4 and 5. So maybe 4.2, 4.9, 4.3, 4.6, 4.8, and exactly 4. Well, in this case, I can only have 6 people that answer exactly 4 because we're dealing with discrete or whole numbers. Okay, so when we graphically represent this, specifically discrete, your numbers can only lie within the bar, sorry, can only lie within that number. A few other pointers you'll notice is that whenever we draw histograms or even a column graphs for that matter, there are always arrows that are pointing both on the x-axis and the y-axis. This is just to indicate that these numbers continuously go on. You won't have numbers displayed within that region here or here, but graphically they do technically go on forever. Second thing you'll also notice is this little squiggly line. It's almost like a line and it goes up and down. This is just to indicate that where 0 technically does start here, but sometimes our first value within our data might stray away or start very far away from the number 0. So this little line here that looks like this just indicates that we're skipping initial numbers. I spelled that incorrectly. There we go. Initial numbers. We're skipping initial numbers, so we're skipping from 0 all the way, and we're going to, in this case, to 4. Technically, I could have drawn this with just a longer line where it went 1, 2, 3, and then 4. Could have started around here. But for this example, we're just going to skip it and go straight to 4. Namely, you would do this when we have a large number as our starting value. So maybe the lowest value within the data set could be 16. And you couldn't be bothered drawing 1, 2, 3, 4, 5. So you'll just put that little line there. Kind of looks like a heartbeat skip of some sort, or pulse of some sort. And this would just be just skipping the initial numbers. Okay. All right. Now let's have a look at the example over here, which is taken from the actual textbook. So we're going to be drawing this histogram. So the table shows the maximum daily temperature recorded to the nearest degree Celsius for a country town in February. Don't know what the country town is, but all you know is that within the month of February, the amount of temperatures that hit 31, the amount of days, there's only one day that hit 31 degrees. There are 2 days that hit 35. There were 5 days that hit 36, etc., etc. For 40, there are 0 days. The reason why we put 0 in this case is because there was a day that was below 40, and obviously higher than 40, 41, 42. We have to consider this number here as a 0. We have to put that number in. If these numbers didn't exist, this frequency will only have to go up to 39. But because 41 and 42 exist, we have to showcase that 0 hit 40. Else there will be no consistency within these graphs here. Okay. Now, I know you're probably asking, why don't we have 32, 33, and 34? Technically, we should. There should be that within here. 32, 33, 34. We should have that with zeros in between there. Not too sure why they didn't put that in. And they just put this 40 here with a 0. Not too sure, it doesn't make sense, but let's just take it for face value. Okay. First question, is the data discrete or continuous? Or in other words, we know it's numerical, but do we have whole numbers or do we have decimal numbers? Now this brings me to that first point that I brought up before. The temperatures that are given are whole numbers. That is correct. They're whole numbers. But temperatures are actually considered as continuous, and the reason why is because it is possible to get temperatures like 36.2 or 37.8. But in the table that's given here, the values that are displayed in a discrete way. It's just being rounded to the nearest degree within the question. So if the answers that are there can be provided, as a decimal, then it's still considered, regardless if there are whole numbers in there, it is still considered as continuous. Okay. And the second question, or the second statement, construct an appropriate histogram or column graph. We're not going to do a column graph because that has to do with categorical data, which is not what we're dealing with. We're dealing with numerical, so we have to do a histogram. And this here, you'll see that little skip pops up because the first minimum is 31, because the information has been displayed to the nearest degree, and even though it's continuous, the numbers are discrete. We would show the bar in between the actual number itself. So there was 1 that hit 31, 32 nothing, 33 nothing, 34 nothing, and then 35 there were 2. So under the bar we would have not 1 but 2. Yeah. And then 36 goes up to 5, etc., etc. Notice that with histograms there are no spaces in between there. There are spaces within the category that's not there. For example, 32, 33, 34, and 40 don't have numbers there, but you still put them in there, but there's still no gaps in between the number representations. Okay. Let's move down there. There we go. So, because we're dealing with histograms, no spaces. A few more important features. The first important feature that I have to show you is that there is a title. There is a title within this histogram. All histograms, or bar charts, or type graphs, charts, regardless of what they are, will always have a title because there's always going to be context to that information. In this case, we're dealing with maximum temperatures. The second thing you notice is that the sides on the y-axis and the x-axis, yes, they have numbers, but they also have context to those numbers. In this case, we're looking at the maximum amount of temperatures within the month of February, and that's going to go on the side. How many days within February was there 37 degrees? There's 7 days within February. And you'll also notice that the context of the numbers on the bottom has to do with temperature, because that was a question there, to the nearest degrees Celsius. So we need to show that temperature, and we also need to show the type. We're not dealing with Fahrenheit. Yeah, in America, we're dealing with degrees Celsius, so that has to be there. Okay. So as long as you got the titles, these right here are considered your labels. Okay. If you have your titles, if you have your labels within your histogram, and you've done it correctly, well, regardless of whether it's discrete or continuous, then you have successfully created a correct histogram. And that concludes this long video, nearly 27 minutes. Apologies, it was a lot of information just for one question. But trust me, you have to know this information in order for you to help yourself within the next vlogs within this topic. Go ahead and attempt question 1 for this exercise for log 4. I will see you guys in the next video. Take care.